हेलो स्टूडेंट्स, आज का हमारा टॉपिक है डेरिवेशन ऑफ हैमिल्टन इक्वेशन और द कैनोनिकल इक्वेशन। फॉर दिस, first of all, we define a Lagrangian function. You know that the Lagrangian function is the function of the coordinate t and the qj and qj naught. Okay, where j is varying from 1 to n, or you can say that L is a function of t, q1, q2, qn and q1 naught up to qn naught, where these all are the Lagrangian variable. ये हमारे क्या है, Lagrangian variables है. Now to replace the Lagrangian variable हमारे यहाँ पर क्या कर रहे हैं, they are describing the state of the system actually. Okay, so we want to introduce some new variables. So हमारे यहाँ पर हैमिल्टन ने कुछ न्यू वेरिएबल इंट्रोड्यूस किए यहाँ पर t, qi एंड pi, जहाँ पर pi आपका क्या है, pi इज कर्ल l ओवर कर्ल qi नोट. ओके, so these variables are introduced newly, okay, which are introduced by this Hamilton. So t, qi, pi, this is your pi. So what you have to do now, we suppose that L is a function of q1, q2, q1 naught, q2 naught up to qn naught, और जो बाकी ये t, q1, q2, qn है उसको हम पैरामीटर कंसीडर करके चल रहे हैं. ओके, सो अभी इससे लास्ट लेक्चर में हमने जो डंकिन्स थ्योरम के बारे में बात की थी, यू नो दैट इफ x, लेट मी रिकॉल दैट इफ x इज ए फंक्शन ऑफ, हमारे पास x फंक्शन था x1 x2 xn का, अगर x इसका फंक्शन है, ओके, सच दैट कर्ल x ओवर कर्ल xi, so that is equal to yi. Okay, so this was the newly variable described by the function capital X. Now there exists a function y such that y is equal to summation xi into yi minus capital X, and where कर्ल y over कर्ल yi is equal to स्मॉल xi. ओके, तो हमारा यहाँ पर क्या था कि अगर x इज ए फंक्शन ऑफ x1 x2 xn सच दैट कर्ल x ओवर कर्ल xi इज इक्वल टू yi, देन देयर एग्जिस्ट अ कैपिटल फंक्शन y विच इज अ फंक्शन ऑफ y1 y2 yn, सच दैट कि अगर उनके बीच में y और x के बीच में रिलेशन ये है, देन कर्ल y ओवर कर्ल yi विल बी इक्वल टू xi. तो ये थी डंकिन थ्योरम हमारी. ओके, तो सिमिलरली here in place of x, what is here, here is L. So L is a function of q1 naught, q2 naught up to qn naught, right, qn naught, such that curl L over curl qi naught, so that is equal to what, it is equal to pi. So what it says, Duncan says that there exists some function, suppose that I call the function h, there exists some function h which is a function of p1, p2, pn, such that curl h over curl pi will be equal to qi naught, right, and this is, sorry, here is also qi naught, सच दैट कि जो h है, h और l के बीच में क्या रिलेशन है, h एंड l के बीच में रिलेशन होगी आपकी pi इंटू qi नॉट माइनस l. ओके, सो दिस इज अबाउट द डंकिन्स थ्योरम. तो हमने यहाँ पर भी यही थ्योरम हमने यूज की है, बस कंडीशन हमारी इसके लिए क्या थी कि डिटर्मिनेंट ऑफ कर्ल स्क्वायर l ओवर कर्ल qi naught into qj naught, that should be non-zero. So these things we are supposing actually. So it is written over here कि L is a function of q1 naught, q2 naught up to qn naught, where t and q1, q2, qn are the parameters. Then such that pi is equal to कर्ल L over कर्ल qi naught जो हमने ऊपर सपोज किया है, and determinant of curl square L over curl Qi naught into Qj naught, where ij is varying from 1 to n is non-zero, then by the Duncan's theorem there exists some function h. H is a function of t, Qi and Pi, or you can say that h is a function of P1, P2, Pn are the variables over there. So h curl h over curl Pi will be equal to Qi naught, where this h will be described by as a summation of Pi into Qi naught minus L. Okay, this is the relation between the h and the L. So now you can say this thing we have by the Duncan's theorem. Now if you differentiate this h with respect to Qi, so what it will be? That will be 0 and it will be minus curl L over curl Qi. Okay, so curl h over curl Qi will be equal to this thing, or if you rewrite this equation, so you can say that curl L over curl Qi will be equal to minus and this side, so you can say that curl L over curl Qi will be equal to minus of curl h over curl Qi, right. Now if you use the Lagrangian equation of motion, so what was that? It was d by dt of curl L over curl Qi naught minus curl L over curl Qi is equal to 0, where I is varying from 1 to n. Okay, then you know that what is this curl L over curl Qi naught? We are calling this as Pi. So this is Pi. So d by dt of Pi is equal to minus of curl L over curl Qi. But what will be the value of curl L over curl Qi? This is minus of curl h over curl Qi. So if I replace it here, so you will say that it will d by dt of Pi will be Pi naught. So Pi naught and minus minus plus. So Pi naught plus it will be curl h over curl Qi, right. That will be equal to 0. So if you find out the value of Pi naught, so Pi naught will be equal to minus of curl h over curl Qi, right. So this will be the value. The same thing I have written over there. This Pi naught will be equal to minus curl h over curl Qi. So you got the two equations. One is above. What is that? This is Qi naught is equal to curl h over curl Pi, and Pi naught is equal to minus of curl h over curl Qi. Okay. So these are the two equations. Pi naught is equal to minus of curl h over curl Qi. So these equations is actually known as the Hamilton equations. Okay. Now the theorem is that we have to prove that dh by dt will be equal to curl h over curl t, and for a generalized conservative system h is a constant energy function. You have to prove it. So as we have discussed, h Hamilton is a function of the Hamilton variables, which is t, Qi and Pi, where I is varying from 1 to n, or you can say that h is a function of t, Q1, Q2, Qn, or P1, P2, Pn, right. If you find out dh by dt, so what will be? You will take the differentiation of this h with respect to t, but h is function of t, Q1, Q2, Qn, and P1, P2, Pn. So obviously the chain rule will be applied over there. So you can say that partial derivative of h with respect to t into dt by dt, with that becomes 1, plus partial derivative of h with respect to q1 into dq1 over dt, okay, that becomes q1 naught with curl h plus curl h over curl q2 into q2 naught plus curl h over curl qn into qn naught. Okay, so उसी को we are combining these things and we are writing this thing as, right. Then curl h over curl p1 into p1 naught plus curl h over curl p2 into p2 naught plus curl h over curl pn into pn naught. When we combine these things, so that will be the summation of this thing, right. So overall combine, we take the summation I is varying from 1 to n, curl h over curl qi into qi naught plus curl h over curl pi into pi naught. But we know that the Hamilton equations. What are the Hamilton equations? We know the value of the qi naught and the pi naught by using the Hamilton equations. So Hamilton equation says that qi naught will be equal to curl h over curl pi. So we place that, and pi naught is equal to minus of curl h over curl qi. So it will be minus of curl h over curl qi. So when I place the value, it is curl h over curl qi, curl h over curl pi minus of curl h over curl qi into curl h over curl pi. So same things are there, so that will be cancelled out. Okay, so that means it becomes 0. So what are the left thing? dh by dt will be equal to curl h over curl t. This thing you have to prove. So we proved now. Now for the generalized conservative system, you have to tell if the system is generalized conservative. So you say that h doesn't depends upon the time. That means time will not enter as a explicit variable. So you say that h as a function of qi and pi. If h is a function of qi and pi, so curl h over curl t, that will be equal to 0. So if this value is 0, so you say that dh by dt, that will be equal to 0. Okay, so dh by dt will be equal to 0. So if you take the integration, so you say that h as a constant. So you say that for the generalized conservative system, h will be constant. That means the total energy will be constant, right? So for the conservative system, we proved that total energy of the system will be constant. Now for the Scleronomic system, we want to find out the relation, what will be the total energy, right? So we will prove it by using this. Now L, you know that L is a quadratic function, which is a quadratic function of generalized velocity, right? So L can be written as L2 plus L1 plus L0, right? And above we have discussed that h as a function of Hamilton function can be written as pi into qi naught minus of L, right, where pi is curl L over curl qi naught. So I place this value, it is curl L over curl qi naught into qi naught. But what is L? L is here L2 plus L1 plus L naught. So I place this value over there, and over here also we will place. Okay. So when I place this value, so it will be curl over curl qi naught of L2 plus L1 plus L naught into qi naught minus of L. And when you take this differentiation individually, you will write down curl L2 over curl qi naught into qi naught plus curl L1 over curl qi naught into qi naught summation plus summation I is varying from 1 to n, right? Here also you can write curl L naught over curl qi naught into qi naught minus of value of L is minus L2 minus L1 minus L naught, right? But we know that L2 is a homogeneous function of degree 2 in generalized velocity. Okay. So you say that if this is a homogeneous function of degree 2 in generalized velocity, so by the Euler theorem of homogeneous function, you can say that this curl L2 over curl qi naught into qi naught, it will be equal to 2 into L2. Okay. So degree of the function into that function you will write down. So what is it? Is a homogeneous function of degree 2, so it will be 2 into L2. Now similarly, when you apply the homogeneous Euler theorem of homogeneous function over here, so L1 is a homogeneous function of degree 1 in generalized velocity. So you say that by Euler theorem, it will be equal to 1 into L1. Okay. Since L0 is a homogeneous function of degree 0, so this summation will be equal to 0 into L0. So it will be 0 into L0. This is 0 into L0. So you say that if these values are there, so it will be replaced by 2L2, this is L1 and this is 0. So I place this value over there. So when you place the value, h will be equal to 2L2 plus L1 plus 0 minus L2 minus L1 minus L0. So when you do it, L1 cancel out and 2L2 minus L2 is L2 minus L0. Okay. So h will be equal to L2 minus L0. Now you know that what is the Lagrangian function? Lagrangian function is written as a difference of the kinetic energy and the potential energy of the system. So L will be equal to T minus pi, where L is L2 plus L1 plus L0 and T, kinetic energy of the system, can be written as sum of the three homogeneous function T2 plus T1 plus T0, and this is potential energy. So when you equate, L2 will be equal to T2, okay, and L1 will be equal to T1 and L0 will be equal to T0 minus pi, right. So this value you can place over there also. Okay. But if we consider the system as a Scleronomic, but for the Scleronomic system, you know that value of the T1, T0 and T2, you know that what are these values? These values for the Scleronomic system, these are the T2, this is T1 and this is T0, right, where AGL is this one, here AJ is using, AJ is this one and A0 is this one, okay. But if we consider the system as a Scleronomic, if the system is Scleronomic, that means that time will not enter as a explicit variable in Ri, okay. If Ri is the position vector of the ith particle, so T will not be enter over there. If T is not enter over there, so we will say that curl Ri over curl T will be equal to 0. If this is equal to 0, so this is present over here and this is present over here, so that means AJ equal to 0 and A0 equal to 0. If A0 is equal to 0, that means T0 equal to 0. If AJ equal to 0, that means T1 equal to 0. So that means T1 and T0 equal to 0. So that's why we have written that T0 and T1 equal to 0. And what is left? T is equal to T0 plus T1 plus T2. So that means T will be equal to only T2. So this thing we have written only. Okay. So as we have said that L2 will be equal to T2, but T2 is equal to T, and this is 0, and L0 will be equal to minus pi, right. So we place the value, L2 is replaced by T and L0 is replaced by minus pi. So we replace over there, L2 is replaced by T and this is replaced by minus pi. So it will be T plus pi. So you say that H will be equal to T plus pi. So what does it mean? That means for the Scleronomic system, the total energy of the system will be given by as a T plus pi, which will be denoted by H. H is nothing but the Hamilton function. Okay. So for the Scleronomic system, we proved it this, and for the conservative system, you proved that H will be equal to some constant, right. So this thing we have proved here. Now the next topic we will discuss in the next class. Thank you, students.